All right, I'm going to go through heat calculations. So we're going to start with this set over here and then continue with this set. So what is the total amount of heat energy in joules absorbed by 25.0 grams of water when the temperature of the water increases from 24.0 degrees Celsius to 36.0 degrees Celsius? All right, so I have, in order to calculate heat, I have 3 formulas, and here it tells me everything that it stands for. What I need to determine first is there a change in temperature? Yes, there is. It tells me a change in temperature. When there is a change in temperature, I have one option right here. So, as we did with the other set of problems previously, we are going to start by writing the formula and our list of variables. Okay, so our formula is Q equals mC delta T. My list of variables, Q, M, C, delta T. All right, so let's see, what is the total amount of heat? That's Q, what I'm trying to find. Absorb, and here we go, 25.0 grams, that is mass. Here is temperature change. So what you have to remember is temperature is final minus initial, always, because I need to get the correct sign. So the final is 36. Minus 24 is 12. So 12 degrees Celsius is the change in temperature. Well, I can't have a second variable. What I need to do is, oh, look, it's water. So water, I have another piece of information. Table B, for water, I have specific heat capacity, which is C, and it is this, 4.18. 4.18 joules per gram Kelvin. Now, if you remember when we talked about this, since the boiling point of water is 100 degrees Celsius, it is 373 Kelvin. The freezing point is 0, it is 273 Kelvin. So there's 100 degrees in between here and 100 degrees in between here. So once we subtract these numbers, I just wanted to know how many degrees are in between them. So then in that case, Celsius and Kelvin are kind of interchangeable in terms of the number of degrees, okay? All right, so now let's plug in our numbers. Q equals 25, 4.18, 12. Okay, this is easy. Straight across, I just multiply. So 25 times 4.18 times 12 equals, Q equals 1254 joules. If I wanted it in kilojoules, take the decimal, which is here at the end, remember, and move it 1, 2, 3, so it would be 1.254 kilojoules. Sometimes the multiple choice answer goes that way. Okay, so this is my answer. I'm going to make it clear and circle my answer. Number 2, determine the total amount of heat released by 5.00 grams of water vapor as it condenses at its boiling point. So remember, I have a list of formulas. Was there any change in temperature? Nope, there was not. So I need one of these two. Well, this is boiling and water vapor, so I need the heat of vaporization formula. So Q equals mHV. Write my variables, Q, M, HV. The only number the problem gives me is 5.00 grams. I want to find heat. Okay, so I have to find that somewhere. Can you guess where? Well, it's water. Water, water, water. Constants for water up here. Heat of vaporization, 2260 joules per gram. 2260 joules per gram. Plug in your numbers. Q equals 5 times 2260. Q equals, let's bring the calculator over. 5 times 2260 equals 11,300 joules. So there's my answer. Can leave it just like that. What if I wanted it in kilojoules? It would be 11.3 kilojoules. What if I wanted it in scientific notation? 1.13 times 10, 1, 2, 3, 4 joules. Okay, those are some options, but you can just stop right here. That is the correct answer. All right, let's go on to the next one. If 3,000 joules of heat are absorbed by a sample of ice at its melting point, how many grams of ice are in the sample? Okay, so do we have a temperature change? No, we do not. Okay, it is talking about melting point. Melting is fusion, so I need this formula. So Q equals MHF, Q MHF. All right, 3,000 joules. What is the mass? Okay, well, I have to know this somewhere. Oh, look at this. This is ice. What is ice? Water. Here we go. Heat of fusion, 334 joules per gram. All right, now let's plug in. 3,000 equals times 334. So all I need to do here is divide both sides by 334, because those will cancel out, and M equals 3,000 divided by 334 equals. All right, so I have 8.982. That's good enough. So the mass is 8.982 grams. I can leave it like that. I can round it to correct number of significant figures, but I can just leave it. This is it. That's it. That's my answer. Okay? All right, let's move on. We're on number 4. What is the specific heat of a substance if 4,520 joules of heat is absorbed by 10.0 grams of a substance as the temperature of the substance increases from 10 degrees Celsius to 30 degrees Celsius? Temperature change, Q equals mCΔT. Variables, Q, M, C, delta T. Okay, 4520 joules, 10 grams, temperature change, final minus initial, right? Final 30 minus initial 20 degrees Celsius is my change, and specific heat is what I'm trying to find. Plug in my numbers. Okay, 4520 equals 10 C20. Let's multiply these on this side. 20 times 10 is 200. So 4520 equals 200 C. Divide by 200. All right. And we're going to be 4520 divided by 200 equals 22.6. Now, what are the units? If I go back to this reference table, since this is specific heat, do you see this? I'm going to use that as my units. So 22.6 joules per gram Kelvin, or joules per gram degrees Celsius is fine. And there is my answer. Okay? All right, let's move on to the next problem. You ready? Number 5. A 150.0 gram sample of a substance absorbs 765 kilojoules of heat at its boiling point without a change in temperature. Determine the heat of vaporization for the substance. Okay, so it says without a change in temperature, and then it says vaporization boiling point. So I need Q equals MHV. Variables MHV. 150.0 grams, 765 kilojoules. Now, here's the thing. The heat of vaporization is typically given in joules per gram. I would have to be careful and list this as kilojoules per gram, or I can just change this right away to joules. So that would be 765,000 joules, because I'd move the decimal 3 over. Okay, so when I put it in the formula, I'll show it both ways. So if I do it this way, 765 equals 150 times HV divided by 150. Okay. 765 divided by 150 equals 5.1. Equals HV, and that is going to be 5.1 kilojoules per gram. And that's not usually our units, so let's plug it in. I could convert this to joules, but I'm going to show you 765. If I converted it in the beginning, which is usually what's easier, HV divide by 150, HV equals, so 765,000 divided by 150 equals 5,100. So 5,100 joules per gram equals HV. So this is correct. This is also correct depending if this were like a multiple choice question or you were just writing the answer, as long as the units matched. If on the exam they tell you the units are joules per gram, this is wrong. So be careful, okay? For number 6, a 5.00 gram sample of liquid ammonia is heated. It absorbs 980 joules of heat. The specific heat is, do you see how specific heat and the heats of vaporization, everything, it's joules? How much did the temperature change? Well, it's asking me to find a temperature change, so I know it's literally this formula. Q equals mT delta T. All right, so 5.00 grams, 980 joules, 4.71 joules per gram Kelvin. This is what we're trying to find. So 980 equals 5, 4.71 delta T. So let's simplify this, multiply those together. 5 times 4.71 equals 23.55. So 980 equals 23.55 times delta T. It means divide both sides by 23.55. So 980 divided by 23.55 equals 41.61 equals delta T. So 41.61 degrees Celsius or degrees Kelvin, it honestly doesn't matter, is the change in temperature. Okay. Now this last one, 300 grams of ethanol at 10 degrees Celsius is heated. What is the final temperature? Okay, this is the hardest kind of question. So it is saying temperature's changing, so I know right away I need this formula. Write my list of variables. 300 grams, 14,640 joules. Specific heat, 2.44 joules per gram degrees Celsius. All right, now it is asking me for final temperature. It tells me the initial is 10 degrees Celsius. This equation will only allow me to find the change, right? So what I'm going to do is solve for change first and use that to find this, and I'll show you what I mean. So 14,640 equals 300, 2.44 delta T. All right, combine those two like terms, so 300 times 2.44, 732, 732 delta T. So I do now 14,640 divided by 732 equals 20. All right, so what does that mean? The temperature changed 20 degrees. Well, it started at 10. So if here's a number line and there's 10, it either went up 20 to 30, or it went down 20, and that would be to 0, so it would be -10, because I was measuring in Celsius, right? So let's go back to the question for the moment. It says 300 grams of ethanol at 10 degrees Celsius is heated. If it's heated, which way was the temperature going? Up. So my final temperature is 30 degrees Celsius. It went up 20 degrees from 10. Now, if you are great in math, instead of doing it this way, okay, you know that the change in temperature is the final minus initial, right? So you could make the equation Q equals MC, instead of delta T, temperature final minus temperature initial. So when you plugged your numbers in, you would get 14,640 equals 300 times 2.44 times TF minus 10, because I only know the initial. Then I would combine these like terms, right? 14,640 equals 732 times TF minus 10. Okay, so then I would have to distribute, right? And then continue solving. So I personally find this way easier, but this is an alternate. I would only recommend it if math is kind of your strong suit, okay? All right, so let's move on to the questions over here. These are the ones that you are going to do independently anyway, but I'm going to go through them in case you are struggling, okay? Or if you're absent, so then you have a resource, okay? So what mass of water can be vaporized with 128,000 joules of heat at 100 degrees Celsius? Okay, so no change in temperature is talking vaporizing. MHV, QMHV. Okay, so heat, 128,000 joules. Mass is what I'm finding. Heat of vaporization, it's water, 2260 from table B, joules per gram. So plug it in, 128,000 equals M times 2260. Take 128,000 divided by 2260 equals 56.64. 56.64 equals M. M equals 56.64 grams. Okay, again, you can write as many of these numbers as you're comfortable with on the exam, unless it tells you a specific number to round to. But typically rounding to tenths or hundredths is going to be good, unless it tells you something different. If it mentions significant figures, then it matters. If it doesn't, guess what? Doesn't matter. So then I would put this right here, 56.64 grams. Okay, next one. A 200 gram sample of water is cooled from, okay, I see a temperature change, mCΔT. As soon as I see a temperature change, I know what my equation is going to be. So 200 grams, final minus initial. So it's cooled from 72 to 14. So 14 minus 72. It matters. Final minus initial. Okay? So, all right, final minus initial. So be careful when you do that. 14 minus 72 equals -58. Just means the temperature decreased 58 degrees Celsius. Okay? How many joules of heat is what I'm trying to find. This is water, so specific heat, 4.18 joules per gram. Plug it in. Q equals M C delta T. So we multiply them together. So we get 200 times 4.18 times -58 equals -48,488 equals -48,488 joules. What does that mean? That means it is exothermic. It's negative. That's all it means. It just means that heat was being released, okay? But the sign matters, so negative 48 joules. Okay, find the specific heat. So as soon as it says find the specific heat, I have one formula that has specific heat, Q equals mC delta T. My list of variables, Q, M, C, delta T. All right, so find the specific heat of 350 grams mass, 34,700 joules heat. Temperature rises, so final 173 minus 22. Okay, so 151 degrees Celsius is my change in temperature. That is what I'm trying to find. So 34,700 equals 350 C 151. Okay, do 350 times 151 equals 52,850 times C equals 34,700. So now take 34,700 divided by 52,850 equals, all right, so 0.657, and it's joules per gram Kelvin or joules per gram degree Celsius equals C. Okay, so 0.657 joules per gram Kelvin or Celsius. That doesn't matter because a degree is a degree. All right, so a 36 gram sample of water has an initial temperature. Okay, so this is again temperature changing. C delta T, Q M C delta T. 36 grams initial, so it's final minus initial. Initial is 22. 1200 joules, and it's water, so 4.18 joules per gram degree Celsius. So I'm trying to find. So 1200 equals 36, 4.18 delta T. Multiply those two together. 36 times 4.18 equals 150.48. Don't round anything yet. We want to save that to the end. Okay, so 1200 divided by 150.48. Oops, I typed that wrong. 1200 divided by 150.48 equals 7.97 is my change in temperature, which is 8 degrees Celsius. You could leave it like this, but literally that's 8, right? So go back to the problem. After the sample absorbs heat, if it absorbs heat, the temperature is going up. So remember, we started at 22, so it's either going to go up 8 or it's going to go down 8. Okay, so up 8 is up to 30. Down 8 would be, what, 14? So what is it? My final temperature is 30 degrees Celsius. Okay? All right. Let us go to the next one. I'm going to stop writing them on the line, but notice I am continuing to circle the answer as that makes it clearer. Okay? All right, so we did this one, round number 5. The temperature of a sample of water changes from 10 to 20 degrees Celsius. Okay, I know which formula I'm using. mC delta T. mC delta T. Okay, changes from, remember it's final minus initial, from 10 to 20. So 20 minus 10. 10 is the change. It's water, 4.18. 418 joules of heat. Okay, now it says here, show a correct numerical setup to calculate the mass. So all I need to do is have the right formula and then put the numbers in the right spot. So 418 equals mass times 4.18 joules per gram degree Celsius. And our change in temperature is 10. That's it. I'm done. This is a correct numerical setup. Psht, done. Finished. Okay? Easy peasy. Next one. How much heat is required to vaporize 20 grams of water at its boiling point? No change in temperature. Vaporizing. So I use this formula. So how much heat? 20 grams. Heat of vaporization from table B, 2260. So Q equals 20 times 2260. 20 times 2260 equals 45,200. And that's joules. If I wanted it, that's the correct answer, done. If I wanted it in kilojoules, it would be 45.2 kilojoules. If I wanted it in scientific notation, it would be 4.52 times 10 to the 4 joules. But this is correct, just like this, okay? But just in case it's multiple choice, you need to be able to figure out how to get to those, okay? All right, so we just did this one. How many grams of ice can be melted? All right, so no change in temperature, it just says it's at 0. And it's melting, so that's fusion. So Q, M, and HF. So 8,354 joules. How many grams? Heat of fusion. Remember, just as a quick recap, we go right here. 334 joules per gram. All right, and plug your numbers in. Q equals MHF. Just write that. So Q 835.4 equals M times 334. So that means I divide both sides by 334. And I get 835.4 divided by 334 equals 25.01. 25.01 equals mass. Mass is 25.01. Circle it, there's my answer. Okay. All right, now we are on to number 8. When 411 joules of heat are added to 12 grams of water at 21 degrees Celsius, what will the final temperature of the water be? Okay, so again, being careful. So Q equals M C delta T Q M C delta T. Delta T is final minus initial. So we have 411 joules, 12.0 grams. It's water, so 4.18 joules per gram Kelvin or degrees Celsius. And the initial temperature is 21. All right, so I'm going to solve for delta T first. So 411 equals 12 times 4.18 times delta T. Do 12 times 4.18. 12 times 4.18 equals 50.16. So 411 equals 50.1. Oops, let me just rewrite that. 411 equals 50.16 times delta T. Okay, so now divide both sides by 50.16. So 411 divided by 50.16 equals 8.19. Okay, so I could just say 8.2. All right, so that means the temperature changed 8.2 degrees. So it was at 21. It either went up 8.2 or it went down 8.2. Let's go back to the question. And it says when 411 joules of heat energy are added, so the temperature went up. So I do 21 plus 8.2 equals 29.2. So 29.2 degrees Celsius is my final temperature. Okay, so that's this one. Now I'm on 9. Show a correct numerical setup to calculate the heat released when 45 grams of steam condenses at 100 degrees Celsius. Okay, so mHV. Okay, so QmHV. 45 grams, 2260 joules per gram. So finding heat. So Q equals 45 times 2260. Because it was steam, that's vaporization. And that's it, because it just said show correct numerical setup. I am done. Number 10. A sample of water is heated, and it gives me two temperatures, which means already I know Q equals mCΔT. Q mCΔT. And remember, it's final minus initial. 15 minus 10 is 5. 125 joules. It's water, so the delta C is 4.18. Mass is what I'm trying to find. So 125 equals mass times 4.18 times 5. So 4.18 times 5, 20.9. 125 equals 20.9 times M divided by 20.9. 125 divided by 20.9 equals 5.98. So M equals 5.98 grams. Here we go. Did this one. Only have 2 left. Are you ready? Okay. How much heat is required to heat 50 grams of water? And we have a temperature change. So Q equals mCΔT. Q mCΔT. So you notice how every time I'm writing the formula, writing my list of variables. Heat is what I'm finding. 50 grams. It's water, so specific heat from table B. And then change in temperature. Final minus initial. 70 minus 40 is 30 degrees Celsius. So Q equals 50 times 4.18 times 30. Now I just do this multiplication. 50 times 4.18 times 30. Q equals 6270 joules. Bam. Done. All right, one more. How much will the temperature of a sample of water change? Okay, so what temperature is changing? mCΔT. Write my list of variables. mCΔT, right? 125 grams. It's water, so specific heat. 4.18. 8,300 joules are added. Okay, so 8,300 equals 125 times 4.18 times delta T. So I'm going to do 125 times 4.18 and get 522.5. Now I'm going to divide both sides by 522.5. Okay, so 8,300 divided by 522.5 equals 15.885. So 15.89 equals delta T. So the change in temperature is going to be 15.89 degrees Celsius. I could say 15.9, even I could round it to 16, depending what the question said. 15.89 or 15.9 is probably the best. Okay? And there we go. This is all of the heat calculations practice.